non-coherent ASK detector or demodulator. We are saying that in this kind of demodulator, the demodulation of the modulated signal, there is no knowledge of the carrier signal phase that is required. We are simply saying that the carrier signal phase is not required. What that means is that the receiver will not require to know what was the phase of the carrier at the transmitter side. So again, in this non-coherent ASK detector will not require phase coherence at the local receiver. So what we are simply saying is that we are simply going, ideally what we are doing here is that we are receiving this ASK modulated signal, which having the highest frequency component being FC. When we pass it through bandpass filter, actually we are taking it through bandpass filter with the frequency lower than this. Actually in the range of 1 over TB, where bit TB is the bit duration. So the frequency of the incoming bits, this is the one that we are going to be putting, setting the bandpass filter center frequency to be. So what that does is that when it passes through this bandpass filter, all these waves that are going up and down are going to be smoothed out. We're going to find that this becomes an envelope. So the output of this at this point will look something like this. Then something like, okay, I should have drawn just that directly below it. So this becomes like that, and then something else like that there, and something else like that there, and then something else like that there. So simply this means it kind of cuts out the high frequency component of the carrier to produce an envelope or like a general shape of the on-off. You see, this now looks like on-off signal or on-off modulated signal. So when we have that, then we just use the envelope detector and the low pass filter. So we are now further going to cut off the any other frequency component, and therefore this becomes one sample. So then we are going to be using the decision making device that is able to sample at different at the rate of, or the sampling frequency of TB or 1 over TB. Therefore, we are able to know that at this instant, if this was a 1, this is a symbol 1, another symbol 1, another symbol 0, that means that this is the TB, the bit duration, another bit duration, another bit duration. So we are able now to detect that if we have a value that is bigger than the threshold set. So this is the decision-making device that is checking at the threshold. If the figure or the value of the amplitude received at this end is bigger than the set threshold, if you recall, we had said that the threshold is normally root of EB divided by 2, because you say that at one side we have the value at 0 of the symbol 0 and at root EB for symbol 1. Therefore, we say that the threshold level is at root EB over 2. So when the received value is less than EB, which is on this region, that means that we interpret the transmitted bit to be at 0. If it is on this range, then we translate or interpret that the transmitted bit is actually a 1, because a 1 is represented by root EB. So and now in few words, we can also say, now we can summarize the operation of the non-coherent ASK data as follows, whereby we say that it involves the rectification. We are kind of rectifying this sinusoidal carrier to become a DC wave, and we are passing it through low pass filter to cut off any high frequency component, and this forms the envelope detector. Then the output is followed by a switching operation at the bit period of TB. Yes, I have said we are sampling this the envelope at the rate of TB, so that after every TB we are determining whether the received bit is a 0 or a 1. The signal is passed through the decision-making device with a preset threshold, which determines whether the received symbol is a 0 or 1. What we also observe here is that there is some complexity of non-coherent ASK demodulator, this one, because there is no product modulator here. We are just talking about an envelope detector. It just determines, does this look like a DC of value of amplitude this, or does it look like a DC input, output of amplitude 0? So that is a simpler circuit compared to the one of the product modulator or demodulator for that matter. So, but you're saying that the error performance is a little poor compared to that of coherent detector. So that now in summary describes how a non-coherent ASK demodulator works.